Good morning, students. Today we are going to discuss about the quadratic polynomials. A quadratic polynomial is a polynomial of degree 2. A polynomial which is having its degree as 2, it is called a quadratic polynomial. That means the highest power of the variable in that polynomial should be equals to 2. So for some examples, let us write p of x equals to means a polynomial with variable x. Quadratic polynomial means its highest exponent of the variable should be 2. So let us write one x square term and x term and one constant. So here x variable is the x and two terms are there here. So here exponent is 1, here 2. 2 is the highest one. So its degree should be 2. So now with some coefficients and binary operations we can write like this. So this is an example for quadratic polynomial, and we can write some more examples like this. P of x equals to uh, x square plus 3x. Okay, this is also a quadratic polynomial even though constant term is not there, but this is a quadratic polynomial because its highest exponent is 2. And one more example we can write like that: p of x equals to x square minus 4. This is also a quadratic polynomial even though x term is not there, because here variable is x and its exponent is 2, so its degree is 2. It is a quadratic polynomial. So the general form of the quadratic polynomial is ax square plus bx plus c. In general, we can represent a quadratic polynomial as like this: ax square plus bx plus c, where a, b, c are the coefficients and a not equal to 0. A should not be equal to 0, because if a is 0, the x square term will be become 0. Okay, so a not equals to 0, the coefficient of x square should not be equal to 0. See, in the first example the x square coefficient is 2, this is small a. Okay, in coefficient of x is 3, this is small b, and the constant is minus 6, this will be considered as c. Okay, so this is in the form of ax square plus bx plus c. In the second example also, coefficient of x square is 1, so that is a, and coefficient of x is 3, that is b. Here constant term is not there, so c value is nothing but 0. Okay, in the last example, coefficient of x square is 1, that is small a, and x term is not given here, so b equal to 0. B is nothing but coefficient of x, and the constant term is minus 4, that is considered as c. Okay, in this way the quadratic polynomial general form is nothing but ax square plus bx plus c. Now the degree of quadratic polynomial is 2. The degree of quadratic polynomial is 2. So it has at most two zeros. At most two zeros. Here at most 2 means the quadratic polynomial may have two zeros or 1 0 or no zeros. Okay, at most means maximum value is 2. That means a quadratic polynomial will not have more than two zeros. It may have two zeros or 1 0 or no zeros. That's why we are saying at most two zeros. So the next topic we have to discuss about finding the zeros of the quadratic polynomial. Okay, so in the question, to find the zeros of the quadratic polynomial, the polynomial may be given like these three methods. Means the polynomial having x square, x and constant terms, and the polynomial may have x square and only x terms, and the polynomial may have x square and constant terms. So we will discuss how to find the zeros for this type of quadratic polynomials. Now one question is given here: find the zeros of the quadratic polynomial x square plus 7x plus 10. So in this given quadratic polynomial, x square term is there and x term is also there, and one constant is also there. So to find the zeros for this quadratic polynomial, first of all we have to make that given polynomial equal to 0. That means x square plus 7x plus 10 equal to 0. Now here you can observe that the coefficient of x square, means it is 1, and the constant term is 10. So you have to multiply the constant term with the coefficient of x square. Multiply constant term with the coefficient of x square. So what we will get here, constant is 10 into coefficient of x square is 1. So this value is 10. 10 ones are 10. So we can write 10 as 1 tens are 10, means 1 is a factor of 10, so we can write it as 1 tens are 10. And next 2 fives are 10. 2 fives are 10. Okay, and 5 twos are is also 10, but already here we have written 2 5, so no need to write again 5 2, and 10 ones are also no need to write. So we can write 10 like 1 tens are and 2 fives are. From these two pairs we have to select one pair. Okay, suppose in the first pair we have 1 and 10, two numbers are there. If you add these two numbers, 1 plus 10, you will get 11. And if you subtract the smaller one from the big number, that is 10 minus 1, you will get 9. Okay, by using the first pair 1 and 10, by adding you are getting 11, by subtracting you are getting 9. Now you should compare that value with the coefficient of x. The coefficient of x is given here as 7. Okay, so by adding you are getting 11, by subtracting you are getting 9, but we didn't get 7. Okay, by adding or subtracting we are not getting 7, so you should not take this pair. Now coming to the next pair, 2 and 5. From these pair, let us check what will happen by adding and subtracting. And 2 plus 5, by adding those two numbers you will get 7, and by subtracting the smaller from the bigger one, 5 minus 2 is equal to 3. Okay, 2 plus 5 is 7, 5 minus 2 is 3. Now here by observing the sum, 2 plus 5 is 7, so that is equal to the coefficient of ex. So we have to consider this pair. Okay, by adding or subtracting you should get the coefficient of x. Okay, so now write those two terms again, 2 and 5, and the variable of the given polynomial is x, so write x for both the numbers, means we are making them as 2x and 5x, and the coefficient of x is having positive symbol, plus symbol. So you have to keep the plus symbol to the bigger one from these two numbers, 2 and 5. 5 is the bigger one, so the coefficient of x having positive symbol, so you have to keep that plus symbol to the bigger number, plus. And next you have to check which symbol we have to take for the smaller number 2x, whether it may be plus or minus. We have to check that one. Okay, so let us see what will happen if we take minus symbol for the smaller number. See, minus 2x plus 5x is here. Minus 2x plus 5x. So which is the bigger one from these two? 5 is the bigger one. It is having positive symbol. So plus, and one number having positive symbol, one number having negative symbol. So both are having different symbols. That means we have to subtract. Means 5x minus 2x, it is nothing but 3x. So okay, so minus 2x plus 5x value we are getting as plus 3x, that is not equal to the 7x. Okay, so this minus symbol is not suitable for the smaller number 2x. So let us try with the positive symbol, plus symbol. Now plus 2x plus 5x is there, so their sum is nothing but plus 7x. So plus 7x is equal to this middle term of the given quadratic polynomial, that is already plus 7x is there. So now write the first term x square as it is, and the constant term plus 10 is also as it is, equals to 0. Okay, all the terms we have to write as it is except the middle term plus 7x. So in place of plus 7x, you have to write these two terms. Okay, that is plus 2x plus 5x. Before going to the next step, you have to check again whether the sum of these two terms is equal to this middle term or not, means the x term. See, plus 2x plus 5x is equal to plus 7x. Okay, now here four terms are there in this equation: x square plus 2x plus 5x plus 10 equal to 0. Now from these two terms, from the first two terms, you have to take the terms common. In the first term, x square means 2x values are there. In 2x, 1x is there. So take x as a common. Now from the first term x square, 1x is there outside. So the remaining x will you have to write in the bracket. Okay, the next plus symbol is there, plus from 2x term x is there outside, so the remaining 2 you should write in the bracket. Okay, so now you can check whether this is correct or wrong. Multiply the x plus 2 with x into x square, and x into plus 2, you will get 2x. Now write this x plus 2 term as it is again, x plus 2, this term which is there in the bracket, write it as again one more time, and now compare with the third term. The third term is plus 5x is there. So from plus 5x, x is already written in the bracket, so the remaining is plus 5. The remaining plus 5 should be written outside. Okay, so that is equals to 0. So now you can check whether this is correct or wrong. So plus 5 into x plus 5x, and plus 5 into 2 plus 10. Okay, that means from 5x plus 10 we have taken 5 as common. Now here we have two terms, that is x into x plus 2 is one term, and 5 into x plus 2 is the another term. From these two terms, x plus 2 is common, so we can write it as x plus 2 times. Okay, that means one time you have to write x plus 2, and in another bracket you have to write the terms which are outside of the bracket, x and here plus 5. So it is x plus 5 equal to 0. Okay, the product of x plus 2 and x plus 5 equal to 0 means, that means either x plus 2 may be equal to 0 or x plus 5 may be equal to 0. Okay, so now to find the x value, x equals to 0, and transporting plus 2 to the right hand side, it will become minus 2. So x equal to 0 minus 2 means it is minus 2. And here also x equal to 0, transporting plus 5 to right side, it will become minus 5. It will become minus 5. So x equals to minus 5. That means minus 2 comma minus 5 are zeros of given polynomial. Let us solve one more question. The given polynomial is x square plus 2x plus 1. So we have to find the zeros for the quadratic polynomial, that is x square plus 2x plus 1, and we have to make it equal to 0. And what is the constant term here? 1 is the constant, and coefficient of x square is 1. So you have to multiply these two values, that is coefficient of x square 1 and constant is 1. So 1 into 1 equals to 1. So we can write the product 1 as only, we can write it as only 1 into 1. 1 ones are 1. Okay, so by observing these this pair, we by adding 1 and 1, so 1 plus 1 you will get 2. Okay, so that is equal to the coefficient of x, that is equal to the coefficient of x. So we can select this pair and write the numbers again, 1 and 1, and the variable of this polynomial is x, so write x for both the numbers. Okay, and the coefficient of x is 2, and that is having a positive symbol, so we have to keep the positive symbol to the bigger one from these two numbers, but both the numbers are same, 1 and 1, so keep the same symbol for both numbers, plus and plus. Okay, so you can check whether it is correct or not. Plus 1x plus 1x, the sum will become 2x, and plus 2x is nothing but the middle term, the x term of the given quadratic polynomial. So now write the x square term as it is, and plus 1 the constant term as it is, and equals to and 0. Okay, and in place of this middle term plus 2x, we have to write these two terms, that is plus 1x plus 1x. Okay, and next here we have four terms now in this equation, x square plus 1x plus 1x plus 1 equal to 0. Now from these two terms, x square plus 1x, let us take x as common, x times, from this x square you have two x terms, that is x into x, one x is there outside, so remaining one more x should be written in the bracket, and next plus symbol is there, plus, and from 1x, from 1x the x is taken as common, so it is outside, so the remaining one you have to write in the bracket, so here you have to write 1. So you can check whether it is correct or wrong. Multiply this x with x into x, x square, and x into plus 1, it is 1x. Okay, now write the this bracket term which is in the bracket, x plus 1, again one more time x plus 1, and compare with the third term, that is plus 1x is there, that x is already written in the bracket x, so the remaining term is plus 1 is there, so we have to write that plus 1 outside. So here you can check again, see plus 1 into x plus 1x, and plus 1 into plus 1, it is plus 1 equals to 0. Now here we have two terms, that is x into x plus 1 and plus 1 into x plus 1. From these two terms we can write x plus 1 as common, that which one is in the bracket, x plus 1 as common. So in the next bracket you have to write the terms which are outside of the bracket, that is here outside x is there, and for the next bracket outside 1 is there, so you have to write these two terms in another bracket, that is x plus 1 equals to 0. Okay, so here the product of here x plus 1 into x plus 1 equal to 0. The product of these two terms is equal to 0 means, that means either the first term x plus 1 may be equal to 0, or either the second term x plus 1 equal to 0. So here to find the value of x equal to 0, and transport this plus 1 to right hand side. Okay, then it will become minus 1, then x equals to 0 minus 1 is nothing but minus 1. In the same way, in the second equation also, x equal to 0, and here again you have to transfer this plus 1 to the right side, so it will become minus 1, and x equals to 0 minus 1 means it is minus 1, that means minus 1. Okay, here we got the answer as x equal to minus 1 and x equal to minus 1. Okay, so x equal to minus 1 comma minus 1 are the zeros of given quadratic polynomial. Okay, here minus 1 is actually 1 0, but it came two times here, that means in the definition of quadratic polynomial already we have mentioned that the quadratic polynomial may have at most two zeros, it may have two zeros or 1 0. In the previous example we got two zeros for that polynomial. Here we got 1 0 for this polynomial. One more question here. Find the zeros of the quadratic polynomial p of x equal to 2x square minus 8x plus 6. So let us make it equal to 0 first. 2x square minus 8x plus 6 equal to 0. Now what is the coefficient of x square? It is 2. And what is the constant here? Plus 6 is there. So by multiplying these two terms, constant 6 and coefficient of x square, it is 2. So 2 into 6, that is equals to 12. So we can write 12 as 1 12s are 12 and 2 6s are 12 and 3 4s are 12. No need to write again 4 3s are and 6 2s are 12 1s are, like that. Okay, so from these pairs you have to check which pair is suitable. Okay, so first take the first pair 1 and 12. By adding 1 and 12 you will get 13, and by subtracting 12 minus 1 you will get 11. Here the coefficient of x is 8. Okay, no need to consider the negative symbol now. From So let us consider only 8 first. So by adding or subtracting we didn't get 8 here, so no need to take this pair. Now coming to the second pair, 2 and 6. By adding 2 and 6, 2 plus 6 equals to 8. Here we got 8. Okay, that is equal to the coefficient of x here. So write the two terms here, 2 and 6, and the variable of this quadratic polynomial is x. So write x for both the numbers, and the coefficient of x is having negative symbol, minus 8 is there. So keep that minus symbol to the bigger one from these two, 2x and 6x. Which is the bigger one? 6 is the bigger one. So you should keep the minus symbol to the bigger one. The coefficient of x having negative symbol here, so you should keep that negative symbol to the bigger one. Okay, so 6 is the bigger one, so keeping minus for 6 here. And now we have to check which symbol should be given to 2x. So whether it is plus or minus, we have to check that. Okay, so let us see, suppose if plus is given for 2x, now what is the result? Plus 2x minus 6x. Plus 2x minus 6x means the bigger first of all you have to write the symbol of the bigger number. Bigger number 6 is having negative symbol, so that is minus, and both the numbers are having opposite symbols. 2x is having positive, 6x is having negative. Opposite symbol means you have to subtract, means 6x minus 2x, it is 4x. So the result is minus 4x, that is not equal to minus 8x, the middle term, the x term. That means this plus symbol is not suitable for 2x. So here you have to take the minus symbol. So minus 2x should be written. Now again you can check whether what is the result of this one. So from this bigger number is 6, it is having minus symbol, so minus, and both the terms are having same symbol, minus. So we have to add them. 2x plus 6x, it is 8x. So the result is minus 8x, and minus 8x is the exactly the x term in the given quadratic polynomial. Now write the first term as it is 2x square, and the constant term as it is plus 6x and equals to and 0. Now in place of minus 8x, the x term, you have to write these two terms, that is minus 2x and minus 6x, minus 6x. So from these first two terms, 2x square minus 2x, here the coefficient of x square is 2 and the coefficient of x is 2. Both are same number, 2 and 2. So you can take 2 as common, and in the first term 2x values are there, and in the second term 1x is there. So 1x is also you have to take as common. So 2x times, now check, from first term 2x square, 2 is there already outside, and from x square 1x is there outside of the bracket. So you have to write the remaining 1x inside the bracket, x. and the next minus symbol is there, so write the minus symbol here. And from the second term, 2 is there already outside and x is also there outside. That means here you have to write only 1. Okay, uh, you can check whether this is right or wrong. See, 2x into x, you have to multiply the terms which are in bracket with outside term 2x. 2x into x is nothing but 2x square, and 2x into minus 1, you will get minus 2x. Now write the term which is in the bracket again, x minus 1 again, and now compare with the third term. Minus 6x is the third term and x is there already in the bracket. The remaining term which you have to write outside is minus 6 equal to 0. Now here we have two terms are there, 2x into x minus 1 and minus 6 into x minus 1. From these two terms, you have to take x minus 1 as common, and in another bracket, you have to write the terms which are outside of the bracket terms. Here 2x is there as a product with x minus 1, and for the second term minus 6 is there. So you have to write those two terms in another bracket, that is 2x minus 6 equal to 0. Now this x minus 1 into 2x minus 6. So the product of these two terms is 0, means that means either x minus 1, the first term should be equal to 0, or the second term should be equal to 0. 2x minus 6 equal to 0. So here to find the value of x equal to 0. Now transport this minus 1 to the right side. So it will become plus 1 plus 1, then x equal to 0 plus 1 means it is 1. And in the second one, 2x equal to 0, transport this minus 6 to right hand side, so it will become plus 6 plus 6. So we can write 2x equals to 0 plus 6 means 6. So here 2x equal to 6 means, so writing that x as it is and equal to and 6 also writing as it is. Now transport this 2 to the right hand side. Here we have to find the value of x. So the terms which are other than x should be transported to the another side. So transporting 2 to the right hand means here on the left side 2 is multiplying x. So whenever it goes to the another side, right side, it should divide the 6 on right hand side. So we will get x equals to, by 2 ones are 2 threes are. So we will get 3. That means here we got x equals to 1, and here one more 0, x equals to 3. Okay. So we can conclude that x equal to 1 comma 3 are the zeros of given quadratic polynomial. Here the given quadratic polynomial has two zeros, 1 and 3. That means in this polynomial, if you substitute 1 in place of x, the polynomial value will become 0. If you substitute 3 in place of x in the polynomial value will become 0. One more question is here. Find the zeros of the quadratic polynomial p of x equal to x square minus 4. So first let us write x square minus 4, the polynomial, equal to 0. And in the previous questions, x square term is given and x term is given and constant term is also there in the previous question. But here only x square is given and constant is given. X term is not there in the given polynomial. Okay, so to find the zeros for this type of polynomial, first we have to write this x square as it is, and the next minus symbol is there, minus, and the constant 4 we have to write it as 2 square. 2 to the power of 2 is nothing but 4, so equal to 0. Now this is in the form of a square minus b square, a square minus b square. What is the formula for a square minus b square? A square minus b square is equals to a plus b into a minus b, a plus b into a minus b. So by using this formula, we have to expand this equation. Okay, So how can we write this one as a square minus b square means a plus b into a minus b equal to 0. So what is a here? X is a and b is nothing but 2. So a plus b means x plus 2, a minus b means x minus 2 equal to 0. So the product of these two terms is 0 means either the first term x plus 2 should equal to 0 or the second term x minus 2 equal to 0. So x equals to 0, and by transporting this plus 2 to the right side, it will give a minus 2. So we can write x equal to 0 minus 2 means x equal to minus 2. Here also x equal to 0 and transporting minus 2 to the right hand side. So it will become plus 2. So x equal to 0 plus 2 means x equals to 2. So x equal to minus 2 and x equals to 2 means in the given polynomial, if you substitute minus 2, it will become 0, or you can substitute 2 in place of x, the polynomial value will become 0. So x equal to minus 2 comma 2 are the zeros of minus 2 comma 2 are the zeros of given quadratic polynomial. One more polynomial is given here, p of x equal to x square minus 3. So let us write as x square minus 3 equal to 0. Okay, here also the x term is not there. So write x square as it is minus, and for 3 this is not a perfect square. So we can write it as root 3 whole square. But by cancelling 2 and square root, you will get 3 as it is. So 3 we are writing it as root 3 whole square and equals to 0. Now this is in the form of a square minus b square. So the formula is a square minus b square is nothing but a plus b times a minus b. So we can write this as a plus b times a minus b equal to 0. Here a is nothing but x, b is nothing but root 3, and a plus b into a minus b means root x minus root 3. So the product of these two terms equal to 0 means either the first term x plus root 3 equal to 0 or second term x minus root 3 equal to 0. So x equals to 0 and transporting this plus root 3 to the right hand side, it will become minus root 3. So x equal to 0 minus root 3 means it is minus root 3. And in the second equation, x equal to 0, and here also by transporting minus root 3 to the right hand side, it will become plus root 3. So x equal to 0 plus root 3 means root 3. So here x equal to minus root 3 and x equals to root 3. That means we can say that minus root 3 comma root 3 are the zeros of given quadratic polynomial, are the zeros of given quadratic polynomial. One more quadratic polynomial is given here, that is 4u square plus 8u. 4u square plus 8u. First make it equals to 0. Here variable is u. U is the variable. Here u square term is there and u term is there, but constant term is not there. So constant is not there. Only u square and u terms are given. Okay. So to find the zeros for this type of quadratic polynomial, first you have to take common from these two terms. So in the first term 4 is there, constant coefficient, and for the second term 8 is the coefficient. For 4 and 8, the common factors are 1, okay, 2 and 4. These are the factors. In one table you will get 4 and 8, in two table you will get 4 and 8, in four table you will get 4 and 8. The highest common factor, that means HCF, is 4. So you have to take 4 as common from these two terms, and in the first term u square means two u terms are there, and in the second one u is there, so you have to take one u as common. Okay, so now from the first term 4 is there already outside, and from u square 1 u is there outside as common, so the remaining one more u should be written in the bracket. Okay, now plus symbol is there, plus, and from, and second term 8 is there, 4 is there already outside. In 4 table where you will get 8 means 4 twos are 8, so you have to write 2 here, and u is there already outside as common. Okay, so equals to 0. So now you can check by multiplying these terms. 4u into u, it is 4u square, and 4u into 2, it is 8u. Now the product of 4u and u plus 2 is 0, means the term 4u equal to 0, and the second term u plus 2 equals to 0. So here, to find the value of u equal to 0, you have to transport this 4 to right side, and on left side 4 is multiplying the variable u, so it should divide on right hand side. So by 4, u equal to 0 by 4 means 0. In a fraction, if the numerator value is 0, the value will become 0, u equal to 0. So in the second equation, u equal to 0, and by transporting plus 2 to the right hand side, it will become minus 2. So u equal to 0 minus 2 means it is minus 2. So u equal to 0 and u equal to minus 2. Okay, that means u equal to, here variable is u for this quadratic polynomial, u equal to 0 comma minus 2 are the zeros of given quadratic polynomial. Given quadratic polynomial. So this topic is very important, finding zeros for quadratic polynomial, because in the fifth chapter you have to solve the quadratic equations by using these methods. Okay, so this topic is important for third chapter polynomials and fifth chapter quadratic equations. Some questions are given here from SSC previous public exam papers. Try to solve these questions.